In this segment, we're going to talk about expression evaluation. C is a language rich with operators, and it's very important to know how the operators allow combination, in what order they're applied. I'm going to show you some very simple cases so you can get the central idea, and the central idea is going to be know how the operator works, know its precedence, and know its associativity. So we're going to start with three very simple variables. As we declare them in C, we would say int A is initialized to 1, equals in, and declaration is the initializer symbol. Int B is initialized to 2, and int C is left uninitialized. Normally, most systems would make that 0. So we have three variables to work with in our code. Here's a very simple expression using those. C is this equals means assigned. So in this case, we are seeing an assignment statement. Read that as C is assigned the expression A plus B, semicolon is a end of the operation. So it's signaling a sequence, what's called a sequence point in the computation. Everything that happens on that line, and then you're finished, and then you go on to the next line. Now, as we know, A was initialized to 1, B was initialized to 2, so we would expect C to become 3. So this is a assignment expression. Inside it is a binary plus operator, and that says C is assigned a value of, and here we use parentheses, A plus B. And parentheses are critical in the C language when you're evaluating expressions, because they always override any other part of the expression's precedence. So they clearly show, if you're confused otherwise, or it's a very complicated expression, that this is how you want the order of evaluation to occur. So as we just said, C becomes 3. That should be straightforward. Let's go on. Precedence. Well, we have something like 16 levels of precedence in C operators. Things that are very low precedence, for example, tend to happen later or last. So assignment itself as an operator has very low precedence. However, certain operations, like unary operations, like the operation negation, which is found when you're doing some logical expressions and where you use the exclamation point, is a very high precedence operator, as is something like auto-increment or auto-decrement, which are operators that use the symbol plus plus and minus minus. And then somewhere in the middle are arithmetic operators. And in the arithmetic operators, you have multiply, for example, which in this case is featured with this star. And that has a higher precedence than simpler arithmetic operations, plus and binary minus. By the way, note that you can also have unary minus and unary plus. And the only reason you would know the difference is context or parenthesization. And a unary operator like these are higher than the corresponding binary plus and minus. So binary plus and minus take 2 arguments, unary takes 1 argument. And then times and indeed things like multiply and divide are higher precedence again. And there's also on that level the remainder operator percent, which again, or sometimes called the modulo operator, remainder operator, which is also a higher precedence, equivalent to a multiply or a divide than the addition operator or subtraction operator. Why is that important? Because if these get mixed up in an expression, you have to know which goes first. The other thing you need to know about is associativity. How do the operators associate? So when you have an operator a plus b plus c, this has got two operators. Which goes first? Do you apply b plus c first and then do a? Or do you do a plus b first and then c? And it turns out that these operators occur left to right. And the overwhelming number of operators are left to right. And we show the equivalent parenthesization here. So we would get a plus b, parentheses, plus c, parentheses, if we wanted to fully parenthesize this expression to make it clear what the implicit order of evaluation based on associativity was. Now, looking at this other expression, a assigned b assigned c assigned 3, we get right to left. That means the c assigned 3 occurs first, then the b is assigned that expression value, then the a is assigned. And what you'd all end up with is everything would end up being 3. All right? Try to absorb that. Make sure you can write code of this kind and know how to evaluate it. And we're going to go on to more complex expressions with different operators involved. Okay, we're going to go on to more complicated expression evaluation. We're going to look at some more involved cases. One of the things that gives a lot of people trouble at first is to remember that tokens like the slash token have different meanings in different contexts. So besides the fact that a slash token can be used to be part of a comment, a single slash is generally a divide in an expression, but that divide could be either the integer divide operator or the floating point divide operator, and that gets determined contextually. Similarly, people have trouble with the remainder or modulo operator, the modulus operator. Somehow they don't use that as much in daily practice, so it's hard for them to remember how that works. Then there are operators that are unique to the C language, and they include auto-increment and auto-decrement, and they are plus plus and minus minus. And then there are operators that are based on assignment, so they are ordinary assignment, but also an operator like plus assign. So you might see plus equals or minus equals. But when you see equals equals, that itself is a logical operator. So context means a lot. And I shouldn't say these things are unique, because while C pioneered much of this stuff, they do get used in typically languages derived from C or with some inspiration for C, so you'll see such operators in Java and C++ as well. Now, if stuff gets too confusing in expressions, then to unconfuse yourself and people reading the code and maintaining the code, use parentheses. And keep in mind that parentheses override the built-in precedence and associativity of the operators. So A times B, which is high precedence, then plus. If you had A times B plus C without parentheses, it would mean that first thing. It would mean first do A times B because of its higher precedence, then add in C. But if you wanted A times B parenthesize C, then you'd have to use parenthesized because that would override the precedence and associativity of those, the built-in ones for those operators. There are also gotchas that you have to keep in mind, and a typical one is the use of divide when it's an integer divide. You don't have this problem with multiply, but 3 divides 7 is going to be 0, whereas 7 divides 3 is going to be 2. And in those cases, there would be a remainder, and the remainder just gets thrown away. But 5 divide 2.0, because 2.0 is a floating point constant, is indeed 2.5, which itself is a floating expression. Finally, the modulo operator, as I say, you have to familiarize yourself with it if you haven't used the idea of modulus for a while. That's just what a remainder is in an integer divide. So 3 modulo 7, a remainder would be 3, or 7 modulo 3, the remainder would be 1. Here's the use of pre and post increment. These are specialized but very useful because they abbreviate what would take some more writing. So the pre-increment, namely plus plus b, what it means is b is assigned b plus 1. So b plus 1, the increment, gets done first. Then the assignment a is assigned the resulting value of b after the increment. In the post case, which has higher precedence, by the way, a assigned b plus plus, it's the equivalent as a is first assigned b. So if b was 5, a would be 5, but then b would become 6. All right, so I hope you'll experiment, and I'm going to show you an experiment right now. I'm going to switch over to my runtime window. So here's some code I wrote earlier to experiment, and this is code that you should try to either copy or write your own code of this kind and just try to check your understanding of evaluation, make sure what gets done on the machine is what you expected. So in the first case, we have equals sign, meaning initialized. So a is initialized to 5, d is initialized to 0. Then we have an expression where c is assigned a minus b. Well, a is 5 and b is 7, so we'd expect 5 minus 7 to be minus 2. So if we use that print statement, we should see a is equal to 5, b is equal to 7, c is equal to minus 2, and d is equal to 0. Now, in this part of the code, we're seeing how integer divide would happen. So 5 integer divides 7, that's going to be 0. D will be equal to 7 divide 5, so that will be 1. If this had been all in floating point environment, if everything had been set up as floating point, then instead you'd have the equivalent of 5/7 in floating point, or 7/5, or 1.4 for D. but that won't happen. You're going to get 0 and 1. Also, further on here, I won't look at the module, I'll let you work that out, but here's an interesting one. Here we see the difference between unary minus and binary minus. And unary minus has higher precedence, so that occurs first. So 5 becomes minus 5, and then we have a binary minus where we subtract 7, positive value 7, and the result should be minus 12. Here we're seeing the difference between prefix, auto increment. So A will move from 5 to 6, but this is postfix auto increment, so B remains 7. So 7 plus 6, C will become 13. But then when the whole thing is executed after assignment, then B will become 8. And here we see the plus assignment operator. So this means whatever D's value was, where in the earlier case D would be minus 12, we would add in 5, so we'd end up with a minus 7. So again, try to understand all this, and then here's the actual running of the program results in these values. And I will write a quiz for you and most likely put something of this kind on the class final. In this segment, we'll talk about the structure of the program that includes declarations and an especially important operator, assignment, and how it relates to expressions as well. And all this is wrapped up with types. So we're going to talk in detail in the next few segments about the type logic of the C programming language. Now, types. Some of the types we've seen already are int and double. There will be other types. There will be other simple types like char, float, unsigned, and then there'll be more complicated types later on that involve structs. For the moment, we'll concentrate on these two distinct types. Int, which is in effect an integer type, supposed to represent precisely the whole numbers, and double, which is a floating point type, which is supposed to represent scientific numbers with a very large range. Now, a simple declaration is going to look like a type followed by an identifier with a semicolon. So here we see a simple example on this side. Then a more complex example is a type identifier followed by the equal sign, the equal character, and an initializer. This is not assignment, this is initialization. It occurs in the declarations. Declarations, by the way, occur at the head of a body of code or at the head of the program. And here we have, again, a very simple example. Int, the variable a assigned to. So there we mean that we're going to, in that piece of code, treat a as something that can get different values as long as they're integer, as long as they fit within the type int, and we'll explain more about what it means to fit in the type int, and 2. Finally, we can have a more complicated type declaration in which we have a list. So here's one of those. Int a assigned or initialized 3, comma. So it's a comma separated list. It can be arbitrarily long, and this has 2 variables, one initialized to 3 and one initialized to 5. Okay, let's restart. Here we have a piece of code that I already typed in. It's supposed to show you an example of the use of elementary declarations and assignments. In this piece of code, again, at the head of what's called the block starts with at open brace. We have a declaration list with initializers. So A is of the type int, B is of the type int, C is of the type int. And if we think about what's stored in their memory location, A is 5, B is 7, C is 6. And then we're going to do a simple averaging, and we're going to use a variable average, and that average is going to be initialized to 0.0, though that may be unnecessary, because it's just good practice to initialize variables, because sometimes when you forget to do that, it can lead to errors if you allow the system to do the initialization for you. Here's a printf that'll show us that we assigned what we've assigned, and then we're going to do an average. And in this average we see A plus B plus C. Normally that's an integer expression. We divide by 3.0. Why? Because if we divide by 3, this will be purely an integer division, and we may have a rounding error. But we want it to be done in double. We're going to talk more about why this occurs as a double. This expression will occur as a double. So this is overall an assignment expression, but conversion would have been, if there was a 3, we would make this an integer expression and then assign it to a double. In this case, this is a double expression assigned to a double, so there's no conversion. Again, as I say, difficult topic, very tricky. We'll talk a lot more about conversion. And here we just print it. So it's a very naive program. Let me escape. And I compiled it already, and let me run it. And sure enough, A is 5, B is 7, C is 6, and the average is indeed the floating point number 6.0.